Okay, so now that we have created our training network, uh, and we are still talking about this lecture on ANN, this video series on ANN without TensorFlow and Keras. So now that we have completed our training network, so what is left is just the defining the testing network or testing the network. So that's pretty easy again, and the next thing that we need is the prediction. So let's define both the functions here, and then we can test it later. So first let me go with the prediction function. Okay, so let me call it as predict, and what it needs, it will need the network and row. Okay, so the outputs that would be given will be feed forward, 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 feed forward, and we need to pass the parameters. What are the parameters here? The network and the row. So again it would be the network comma row. Alright, so this is good to go for the prediction. So what would be the output that we need to return it? Dot index max output. So the reason why we are using this max function here is because whenever you remember our diagram, or let me just take you to the diagram. Okay, so here is our output layer. So basically, as we know that we have two output perceptrons here. One is this, and the second one is this. This is the first one, and this is a second one. So definitely this perceptron as well as this perceptron will produce some value. Suppose the output of this perceptron is 0.9. This is point, okay, and the output of this perceptron is 0.92. So the lower one perceptron, I mean this one perceptron is greater, this one is greater. So this perceptron is our valid output according to the network. So then this value should be repeated, or the index of this perceptron should be repeated, I mean given out as output. So that's why we are using the max function here, and we are showing that the maximum value of the two will be given out as output from the total list that we are receiving. The maximum of it will be given out as output. Okay, so here comes our predict function, and we are ready with it. The only thing that we need is a self, because this is defined inside a class. The other one is a test network. So for this we need the self as well, the network and the data. Okay, so basically this will go similarly as our training set. Well, it is a good practice that the test data is also used to train the model, but for here we will just go for the testing part. So suppose we need this portion for row in data, and then we are going to get the outputs will be self dot feed forward, and then it needs the network row minus 1. Okay, so and it will be providing us with the expected equals 0 for I in logical range outputs will be true. As we know, we have not passing anything, so we'll just keep it this way. And expected row minus 1 equals 1. Okay, so here we have got the data as well. So what we need is the error part, or the accuracy, how much it is detecting. So the outputs will be taken in the outputs model, and what we need to do is find the accuracy. So for that we will just find the error. It has error plus equals sum of expected I minus outputs of I in range of len of expected. Okay, now we are done with this. Close this one and close this one. Okay, something, have I missed anything? 1 2. Okay, so here there will be, okay, now this is okay. So this would be our error. So after it has calculated the error, we will move out of this, and every time it has calculated the error, we'll just do one thing. We will take the we'll print the error percentage, which will be equal to comma error. Okay, so what we'll do here, err will be equals to sum error divided by, since we are sending a total outputs, we cannot calculate every time. So we can do one thing, we can take the expected value, sum of expected of I for I in range len of expected and here we go, and multiplied with 100.0. Okay, so let's just cover this up with one brackets, and here is a sum error. So it will produce you with the error, and if you want the accuracy, you can just print it equals comma 100 minus error. Okay, so here we are good to go. So the only thing left is testing. So ready with the testing portion. We are ready to test. So let's do one thing, let's just predict first and then we'll test it. Suppose we have data, let's call it row itself, and we keep any value 1.87 comma 1.72 and keep it seal. So what we are going to do, we are going to predict it. So we need to train it first, and then s dot print let's take it L equals s dot predict predict, and it needs the network comma row. Okay, so if L equals 0, print false. Now print perceptron 1 executed, else print perceptron 2 executed. Okay, the one more thing that in the predict portion we will not have the 0, because that is what we are going to predict, right? So we are not going to send this 0 at all. Let's just run it. Okay, it is showing some error. Feed forward is not defined. So it is saying feed forward is not defined. So what was the name? Okay, this should be self dot feed forward. I've missed this. This should be self dot feed forward. And let's see. Again, output is also not defined. Max of outputs. This should be outputs. Again. Okay. So here means the prediction is perceptron 2 is executed. That means the output that we have got is 1. Okay. So maybe correct, maybe wrong, we don't know about that. So what shall we do? We need to pass certain values. Let's do one thing. We take 3-4 values from here, and then we just check whether our testing portion is working fine or not. So what we are going to do, s dot test I believe, and what were the parameters? Network and data. Network comma data 2. Okay, so this is enough, and this one we are keeping it like this, so we don't need these as well. We just delete this one. Okay, so let's check this now. Okay. Again some error referenced before assignment. Okay, there is. Okay, I got it where I missed this one. So we did not define it, and we have used it before we have defined it. Like in test we have not defined the sum error to be 0, so we need to define it first. Sum error equals 0. Now it will work. Run x name actually this should be expected, and I've made a spelling mistake here. Expected here, and definitely that should be in test only. Yeah, expected. So now run it. Okay, so after a small correction, which is that we need to produce a small if else statement. Like suppose we have taken a variable correct which is 0 initially, and this is a counter. How the number of times the correct result will be outputted, so it will increase it by +1. At last we are predicting the accuracy, and we are checking the accuracy through this function, and then we are printing it. So now it's time to call our um, test function. So it is showing 87% accuracy, so that's pretty good. and means for such small data set, this is a random data, so it may show anything. So here we come to the end of this session, and as well as the series of uh, ANN using from scratch without using any fancy libraries like TensorFlow or Keras. Just go on and practice it, and definitely you'll get this through. So thank you, and just keep in mind that backprop is the most important portion here, and you need to know the concepts of backprop very nicely in order to go through the other portions. Okay, because that is the main portion where the training part is going on. Okay, thank you.